Approximately 13.75 billion years ago, the universe as we know it was born. Soon after, primordial light began to travel through the cosmos, illuminating the early universe. During this period, the universe itself underwent rapid expansion. This initial inflation slowed down, but the rate of expansion has been steadily increasing due to the influence of dark energy. Essentially, the universe has been expanding at an accelerating pace since its inception. For centuries, physicists and mathematicians have explored the mysteries of the universe, seeking to understand its nature. Some scientists go even further, contemplating what might exist beyond the boundaries of our universe. Could there be something beyond our known universe? Possibly other universes or worlds that we can only speculate about. Here are 5 theories about what might lie beyond and the evidence supporting these ideas. If you enjoy our videos, please support us by giving a thumbs up, subscribing to Space Bureau, and looking forward to our future content. Hubble Volume. The concept of outside the universe is complex, as it requires a precise definition of the universe itself. A more accurate term is the observable universe, where the speed of light is a key factor. We can only see objects whose light has reached us, meaning we cannot see beyond the distance light has traveled since the universe's beginning. Cosmologists estimate that the oldest photons we can observe have traveled 47 billion light years since the Big Bang. Therefore, our observable universe spans approximately 93 billion light years. This region contains all the quarks, quasars, stars, planets, nebula, black holes ever recorded, and everything else that may be observable but unseen. The observable universe is expanding as more light reaches us over time. However, the universe is finite, a limit known as the Hubble Volume, named after the Hubble telescope that has provided our farthest views of the universe. We can never observe beyond this boundary, making it the only universe we can interact with. Despite our current observational limits, we are almost certain that there is more universe beyond what we can see. Astronomers suggest that the unseen parts of space could also be infinite, with matter, such as energy and galaxies, distributed similarly to the observable universe. Beyond the Hubble Volume, there are likely not only more planets, but also ones very much like Earth. If we venture far enough, we might find another solar system with an Earth identical to ours, where you had cereal for breakfast instead of eggs. There could be another world where you skipped breakfast, or even one where you got up and committed a bank robbery. Cosmologists propose that far beyond our observable universe, there could be another Hubble Volume exactly like ours. In these other Hubble Volumes, there would be versions of you living out every possible action you might take. While this idea seems improbable, the concept of an infinite universe is beyond human comprehension. To put it simply, according to the theory of relativity, objects close to each other cannot move faster than the speed of light relative to one another. However, this restriction does not apply to objects extremely far apart when the space between them is expanding. This means that objects aren't moving faster than the speed of light themselves. Rather, the space between them is expanding, causing them to recede from each other at astonishing speeds. Consequently, we could only reach the edge of the observable universe if we developed a way to either travel faster than the speed of light, which most physicists deem impossible, or transcend space-time via methods like wormholes or warp drives, which are also considered impossible by most physicists. Dark flow. In 2008, astronomers made a surprising discovery. Galactic clusters were moving in the same direction at extraordinary speeds, exceeding 2 million miles per hour. This phenomenon, known as dark flow, was confirmed by new observations in 2010. Scientists identified dark flow by examining giant galaxy clusters, which are massive collections of about 1,000 galaxies and extremely hot gas that emits X-rays. By observing the interaction between these X-rays and the cosmic microwave background, CMB, radiation left over from the Big Bang, they could study the movement of these clusters. The X-rays scatter photons into the CMB, creating a temperature shift known as the Sunyaev-Zeldovich (SE) kinematic effect. This effect was first noticed by a team led by Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center. They examined around 700 clusters up to 6 billion light-years away, comparing these clusters with the CMB map taken by NASA's Wilkinson Microwave Anisotropy Probe. The movement of these clusters contradicted all predictions about mass distribution in the universe following the Big Bang. One possible explanation is the gravitational pull from massive structures outside the Hubble volume. Scientists believe that these structures, likely beyond our observable universe, suggest that the universe's structure is not uniform beyond our viewpoint. These structures could be anything from vast accumulations of matter and energy to strange fault lines conducting gravitational forces from other universes. Infinity bubbles. Discussing regions beyond the Hubble volume can be misleading because it still pertains to the same universe, just parts we cannot see. The same physical laws and constants apply. Another theory suggests that after the Big Bang, the universe's expansion led to the formation of bubbles in space. Each bubble ceased expanding with the rest of space, forming its own universe with its own physical laws and constants. In this scenario, space is infinite, and each bubble is also infinite, since a single infinity can contain an infinite number of infinities. Even if one could somehow cross the boundary of one bubble, the space between bubbles would continue to expand, making it impossible to reach another bubble regardless of speed. Black holes. Physicist Lee Smolin proposed the theory of fertile universes, which suggests that every black hole in our universe creates a new universe. Each new universe would have slightly different physical laws from its parent universe. This theory implies a form of natural selection for universes. Those with laws and conditions favoring black hole formation would generate more universes, while those without black holes would cease to exist. However, this theory has since been disproved by Smolin himself and others. Infinitely, many parallel universes. There are countless theories about parallel universes, but the most prominent today is an extension of string theory. This theory involves oscillating membranes, or branes, in higher dimensions. While it's beyond the scope of this video to delve deeply into string or membrane theory, the essence is that these vibrating branes in the 11th dimension represent completely different universes. When these branes collide, they can create new universes. The wave-like motions of the branes help explain the observed distribution of matter in our universe. One of the most intriguing aspects of the theory is that the gravity we experience might be leaking into our universe from another universe in a different dimension, which could explain why gravity seems weaker compared to other fundamental forces. What do you think? Do other unknown worlds exist outside our universe? Does infinity exist? And if so, how infinite is it? Parallel universes, warping of matter, string theory, membranes, and black holes. Do you believe these ideas are just science fiction, or could there be some truth to them? Share your opinion in the